Advanced unit testing. It's the place we'll cover next because we need some good kinds of topics to really dive into TDD a little bit more effectively. Now, TDD is all about unit testing. It's all about building those tests first, red, green, refactor. But once you get deep into unit testing, there's a couple things you need to know. And those things are around things like mock objects, stub objects, isolation frameworks, fakes, dependency injection, all these kind of scary sounding potential things. But they make your life a lot easier as you start to unit test. And what you do when you're learning to unit test is you start by just unit testing with the unit test frameworks, and then you gradually run into a pain where you're like, how come this is so hard to unit test? And you ask a more senior or seasoned unit tester, and they'll say, you've got an inversion of control problem. You need a dependency injection framework. Or they'll say something just as cryptic, and you'll go down another path learning to bring in other tools, not just the unit test tools, to help make your life easier as a TDDer.
Yeah, exactly. So this module is kind of designed to familiarize you with different terms that you'll hear thrown around with unit testing once you get to be a more advanced unit tester.
Yeah, and it's a great way for you to start just getting the ideas around it as a launching point to go do it. It's beyond the scope of this course to dive into things like dependency injection frameworks or even mocking frameworks in any level of depth, but it does make sense for us to cover them so that you have an idea of where to look and what you should be looking for when you start to create mocks, stubs, and dependency injection frameworks. So let's jump right in. First, let's talk about stubs.
Yeah, so there are a couple of definitions that we just kind of want you to know of. The first is external dependencies. Now, you may already know what external dependencies are because there's a very good chance that you already use them, but those are objects in the systems that code under test interacts with over and over, in which you don't have control. So it's file systems, databases, threads, libraries. Those are just a few examples of external dependencies that you may have. And it's important to note that because when you're working with unit tests, generally you don't want to hit those live external dependencies. Those are what you will use for integration tests instead. So the idea is that you have these external dependencies, but you don't want to test live dependencies. So how do you actually do that?
That's the trick. And I want to cover one last thing. You mentioned all those external dependencies, and I think there's one unifying theme. Unit tests tend to run in memory. They tend to run right there in memory, and they don't take a dependency on all those external things. No printers, no file systems, nothing outside of just that memory and the compute space that they're in. So how do you get rid of a database?
One of the ways that we can do this is using something called a stub. And that's essentially a controllable replacement for those dependencies. You test the code without dealing with the dependency directly, which seems like kind of a crazy idea, but it is possible. An example of that is, let's say that you work for NASA and you want to train these astronauts to handle working in space. Now, it's probably not a good idea to just send them out to space and say, here's your training, good luck. But what you can actually do is, you can have you could have a stub or have some like a fake basically that you can just train them without sending them to space.
Yeah, exactly. You might use something like a simulator. You might have all sorts of different simulators that you'll build on ground that kind of try to give that same experience back to folks. The example I like to use for a stub in the computer science world is your method calls a logging. It goes and it logs something somewhere. And when you go to log something somewhere, you need to get the response back that says, yes, I logged it successfully, potentially. Let's say that's the case. Well, what you would do is you would use a stub that all it did, instead of the real logging framework, you'd pass in the stub logging framework, and no matter what you send it, it comes back with, got it, successfully logged. It doesn't do anything. It just dumps it. But it comes back and says, got it, because that's part of the things that your method does, but yet you're testing the method and the business logic in the method. You're not testing, did it write to the file system? That's an integration test. You're instead testing other logic in the system, and you want to abstract away the dependencies to write to the file system.
Definitely. And another definition that you'll want to familiarize yourself with is something called a mock object. Now, it sounds kind of vaguely familiar with stubs, and essentially what a mock object is, it's a simulated object that mimics the behavior of real objects. Sound kind of familiar? But it is different, and they do have distinctions, and we'll talk about that in a little bit. But the reasons that you would want to use mock objects is to isolate your test to a unit's scope, just a single unit, not, just like Steve said, having to be in memory. And you could also control that behavior of the code being called and just keep it from, calling a database accidentally or something like that.
Yeah, and let's use another potential example for a mock object inside of a unit test to differentiate it with a stub. You might have a logging framework that when you send it, you're sending it logging messages, and if you send it a message longer than 128 characters, it comes back to you and says, unable to log for some reason or another. Or you send it a file path on a Windows system that's longer than 259 characters. That might be a legitimate thing. And what you want is the mock object to send you back the right response given the data that you send it. So if you send it a reasonable one, it gives you back a success. If you send it an unreasonably length file path, it sends you back a failure with an appropriate error message. And it might keep a log, and another example is that logger might keep a log of what it wrote. So you may say, this would be a different example of a different mock, but you'd say, hey, write this. And then it would come back and say, this is what I wrote, when you ask it what you wrote. So again, kind of similar. I think one way to think about it, Sachi, you taught me this way, is stubs, they're there just to fake out the system. They don't impact your unit test. They should never fail your unit test, right? They shouldn't be part of that failure. Whereas a mock object, how do you put it, has its own internal state?
Maybe. I mean, in a way, I guess it's just, it has the possibility of failing a test.
Yeah, it contains some state, and if you send it things in an appropriate order, it may come back, and its response may be such that it fails the test. And that's not neither a good thing nor a bad thing. It's just a thing that mock objects contain a little bit of state, they remember things, and they can be used to behave differently depending on those inputs, whereas a stub is usually just pretty simple.
Yeah, and another way to think of it too is that another interpretation is that when you're actually doing your assertions against, the classes under tests, when you're using a stub, you're actually just basically just using it to stub out, to be, to fake out the dependency, and the assertion is going to the class under the test. But if you're using something like a mock object, then you're asserting, against that mock object itself rather than the class under test.
Exactly. So let's take a look at the slide where we kind of try to explain stubs versus mocks. And again, it's pretty fuzzy. I think a great place is Martin Fowler's article.
Yeah, mocks aren't stubs.
Yes, mocks aren't stubs. And you can kind of learn about some of those.
Yeah, and one of the main takeaways when I read that article was that Martin really tries to just describe that stubs are state verification and mocks are behavior verification. So those are two very separate ideas, right?
And I really like that definition because it's a clean one for stubs versus mocks.
Yeah, exactly. And of course, other people have different interpretations of the differences, but generally that's kind of the idea of how those are different.
You got an example here that you grabbed from Mocks Aren't Stubs. Tell us a little bit about that.
Yeah, so on the left, you'll notice that there is an example of a stub. And you'll see in this code, it says public class mail service stub implements mail service. Now that's the stub itself. If you take a look at the class, then it's essentially referencing that stub. And then in the assertion, it is basically grabbing mailer.numbers sent, right? But what it's actually doing is it's not doing the assertion against the stub itself, right? And if you take a look at the mock, then you have mock warehouse, mock mailer, and then you have essentially you have the it's expecting return value of false, and so that's actually hitting the mock object itself. So you can tell that those are two very different ways of doing it, and I think that's what kind of cemented it for me that these are actually different entities. They aren't the same kind of way of doing that.
Now you can build your own mock objects. You just fire them up and start typing away. Usually you have an interface so that if you're using the logger, you have an iLogger interface. Your file system logger and then your mock logger, and you have that interface to help you differentiate those in compiled languages like C#, Java, VB.NET, any of the .NET languages. In non-languages, compiled languages like Python or Ruby on Rails, or Ruby rather, you might not be using interfaces because they, if it walks like a duck, talks like a duck, or quacks like a duck, it's a duck. That whole thing. So it depends on the language that you're using on whether or not you need to abstract away that interface. However, building them yourself, that can be painful.
Yes, it definitely can, and there are also some disadvantages with it because you may make mistakes in it, and it's kind of like the idea of why build something if it already exists, in some ways, right?
Yeah.
So we do have there are tons of frameworks out there for .NET. There's some frameworks out there for Java, even C++, and it just kind of depends on the language that you're using. But one example of an isolation framework is RhinoMox. And now if you take a look at the slide, this is just a .NET dynamic mocking framework. And here's an example that I just took from their webpage. It's called Hibernating Rhinos. Isn't that awesome?
I love that.
Yeah, and so this is what you would use to make a mock object. So in this example, you have a variable called mockfoo repository. And so what it's actually doing is this example is generating a stub because it's calling mock repository.generate stub. And then you can just use that stub that's created with RhinoMox and then use it for your act and assert in your unit test.
Excellent. So those types of mocking frameworks, there's other ones besides RhinoMox as well. Mock is another very popular one, extremely simple. It provides link to mocks, so if you're using link, that's wonderful.
Yep.
It doesn't differentiate between mocks and stubs. Everything's just kind of mocks. It's just everything's treated as a mock. Stubs are just mocks that don't happen to have any state-based behavior behind them. They're just property-based behaviors. But you can use a lot of these wonderful frameworks. You're going to end up using a framework at some point in your career if you're doing unit tests. It's just too hard not to use a framework. For instance, here's one of the reasons for me is when you build a framework, when you're using a framework, rather than type out and compile a class, you can simply dynamically create one and say, I expect this to come back when I use it. And that's what RhinoMox and mocks are very much used for. We've talked a lot about mocks and stubs. I think we probably ought to wrap this one and get into the next topic.